Well, let's bring it back. Disagreements. I see Uno one disagreement in part number 4. I think these two things are the exact same, but this should be a log anyway. It should be a log radio. So there are no disagreements? Pardon? Oh, okay, see me. Yeah.
Are you ready?
Oh, I'm always ready.
Y'all are ready for this?
Yeah. Spirit fingers.
Oh.
Okay.
Because he throws them. He drops his spear.
Yeah, drop the spear. Why he was hungry this hour of the day? You see, that's why I'm doing the commercial with you.
They don't work with it. Too big.
That's true though.
You gotta be somebody like me.
No, we're still going to show, right? we'll still find a way to do that. So on A, we agree that this is not a disagreement, technically, right? This person just didn't finish their work. All right? Because remember, if it's a multiplier, it becomes an exponent, right? And this person also didn't finish their work, because it should be a log. All right? So don't stop too early. Okay. Don't drop the mic too early. You listen to the black eye? You should have lied to me at least. Okay, so that's fine. So everything in 4 seems to be fine. That's good. I'm hoping everybody agree with it and like everybody did their homework. Otherwise, we have some problems. Emmanuel, where did you disagree? Which one? E? Okay, let's look at E. So 5E is the disagreement. So let's look at that. That's my laptop. Smack. So 5E is the log of 1 over 10x squared z. Right? And the instruction is to write it as a logarithm, right? Well, it means to just expand it. All right, remember we had the expansion and the condensed form? So, do you remember the time, right, Michael Jackson? There's a property that we use that says 1 over x is the same as negative of that, right? So here's our entire x, right? We could do that. So this is the same as negative the log of 10x squared z. Right? So negative the log of 10, because now it's all multiplication, right? So we'll keep this negative outside, plus the log of x squared plus the log of z, right? And this is still negative the log of 10 plus 2 times the log of x plus the log of z. Do we know what the log of 10 is? 1. Okay. So this is negative 1 plus 2 times the log of x plus the log of z. So negative of that whole thing, right? And if you stopped here, I mean, depending on if you came to us from Odyssey, or what? Could be okay. But for those of you who came from Arbrown to BC, we don't stop here. We just distribute a negative to everything, right? You get a negative, you get a negative, you get a negative. Everybody gets a negative. How you doing? So, can everybody see down here? Because I got some giant kids sitting in front of you with some big heads. So, -1 minus 2, the log of x minus the log of z. You see now they all have negatives, which means it was just a division, which is where we came from. That's a Goya. That's art. It's better than a Rembrandt or Picasso. It's a Goya. If I find my autograph. Copyrighted. My find it's a registered trademark too. Well, my registered trademark. Where's my black marker? I gotta do a blue pie. Just assume it's a black pie. But on a serious note, are we good? Anybody with a question?
How does that?
7?
Oh, is that 7?
That's the C.
Oh, okay.
Z from here. Okay, now today's work, because we're leading into solving now. So just like I did with the crew before you, I'm going to do 6 and 7 and 8, and your work is 9, 10, 11. The reason I'm not going to skip 6 and 7, because that's Goya kind of a test material, right? It has fractions in it, so I'm going to do them, because I will ask you to do stuff like that. So, let's do them. So I'm just going to leave this signature on the board, because a lot of you keep trying to get my art for free. I'm going to leave that as a will to my kids. I'm going to steal from my babies. Let's do number 6. Number 6 wants us to express the log of 1 over x minus 1 over x plus 1. Plus the log of 1 over x. And that's also a minus x plus 1. Oh, you're going to need like a lot of writing space. So you should get your notebook out. So that's what I want us to do, is to express that as a single log. I'm going to need people to get out their notes, notebooks, because we need a lot more space to do this.
So, Mr. Glenn,
How are you doing?
I have something like this, right? The homework, what I did was, plus like, every single number, and put it in work. Is that how you do it?
Every single number has what it wants.
Like if I look at something like that, right, and I did on the homework, I would plus all the ones, and then I would put it.
Well, the only way we can plus one, the only way we can do that is if they have common denominators. It's the only time we add up the numerators, because they're fractions. So in order for us to compare them, adding or subtracting, we have to make sure they have common denominators. We ready? All right. So here's the first thing. Michael Jackson, if I have Are you ready? If I have a third minus a half, how would I start solving it?
You have to make a denominator.
Common denominator? Okay. So what would be their common denominator? Why?
Because we have 6.
How did you figure that? Because we multiply the denominators here, right? To find out what they have in common, right? So same thing here. This is an x and an x plus 1. So to have a common denominator is going to be x times x plus 1. Okay? Just like we had a 6. So this is going to be the log of let's deal with what's in here. I'm going to keep going back and forth between the numerical example so we know what we're doing with the variables. Okay? So you told me that we should have 6 here as the common denominator, right? We all agree, right? So 3 times 2, right? This is our 3 times 2. So this is our 6. Okay? All right. What does this become? What does this 1/3 become?
2, 6.
Why?
Because 3 times 2 is.
Because we're multiplying by this denominator. We multiply this one by this denominator. You see that? And so that would be a 2, because 2 times 1. What would this be? Why? Because we're multiplying also by this denominator, right? So technically, this is what you always do. We are multiplying by the opposite denominator. Okay, that? Because this already has a 3. To make it a 6, we got to bring this 2. This already has a 2. To make it a 6, we got to bring this 3. Diversity. That's what it is. Everybody to be represented on it. All right? Well, that's what people keep asking for. Right? When we're talking about policing, we're talking about police that represent the community that they serve, right? We're saying bring more people that understand all the communities that are involved in that area. Right? That's it. So if you pull a Liberian over, if you have a Liberian police officer, they will know exactly what's going on. Because in my country, when the police pull me over, I'm supposed to walk to them. Yeah, exactly. She go, what? But if you do that here, it's going to be a problem, right?
There you go.
There you go. So that's what we're asking for, diversity. It's the same thing here we're doing with what we compare. We're good? So now there is a 1 here. But this one already has the x, right? What is missing is the x plus 1, right? So I'm going to multiply 1 by x plus 1. What's x plus 1 times 1?
X plus 1.
X plus 1. It is, it's math. It has to be fun. Otherwise, it's just something else. I get it. This already has the x plus 1, right? So that is represented here. In order for us to diversify this, put in an x, right? So what's x times 1? See that? Anybody with a question? Yeah, I just multiply them by the opposite.
Oh.
Alright. Questions? Okay, so now in here, because of this, I'm doing division. Right? Because of this. So it's going to be this thing divided by that thing. So the log of this thing divided by that thing.
You can separate that, right? And make a subtraction.
Oh yeah, well it's already a
Oh, yeah,
subtraction.
so you move it to the bottom.
So right, because I'm going to change that, right? Because it's a subtraction, so we can condense here some of these. So here, now we have a common denominator, right? Correct? Because that's the whole reason we did the entire thing, right? We have a diversified group of people talking to our police officers, so that when the Liberian walks to them, they know that it's just cordial. All right? Same reason we've been pushing for people to have gender-neutral restrooms in this building, right? So that everybody be represented. Okay, so now, are we ready? X plus 1 minus X. What do we get? So, let's look at this. X plus 1 minus X. What would that be? 1, because these two are going away, right? Are we good? Questions? So on this end, whenever we divide fractions, we keep the first, we change the sign, and what do we do with the next? Flip it, right? Or you leave the signs and cross multiply, either way. So every time we divide fractions, we keep the first, we change the next one to the inverse of division, which is multiplication. And because we do that, we have to flip the other one. Or you can leave it as a division and just cross multiply. Okay? Either way you get the same. Anybody else with another question? We're good? So what do I get here? What would be my answer over there? What? X plus 1 over X, right? You ready? You ready? Here's another Michael Jackson moment. Oh, it's already up here. Remember this property that says the log of 1 over x is just the negative of the log of x? Here's our 1 over x. Alright? Which is just negative log of x times x plus 1. Right? I can do that, right? Correct? Because it's a division, I can make the subtractions. Alright? So let me bring it up this way. For those of you in the bag that were stored as Goya. Now this is a multiplication in here. So I change that to what? Addition. So this is the log of x plus the log of x plus 1. This is this piece. Right? Let me do this right. be minus the log of x plus 1. Plus the log of x plus 1. Okay, so let's do this. So we have, yeah, stop smacking. Yep.
What happens with the minus in front of
Oh, yes, thank you, because this minus applies to everything here, right? So minus, thank you.
A is wild. Yes, I do.
Okay, let's do this. This piece and that piece goes away, right? Correct? So what I'm left with is negative log of x, negative log of x. What does that give me? There is a 1 and a 1 here. What's,
Oh, never mind.
fractions are never going to go away. Rational numbers, right? We call them fractions when we were in third grade. We just call them rational numbers now, but it's the same thing we still do. Everything you did with the 3 and the 2, getting a common denominator, is the same thing we're doing with the x and the x plus 1 to get a common denominator. Okay? That's why I say have this on this side. Because if you remember everything you did in third grade, you can still do what you got here in 11th grade, or 12th grade, or advanced 10th grade, whichever one you want. We're good? Questions? Anybody have a question? All right. The next one I promised to do is number 7. So let's look at number 7. I'm hoping people are taking notes and not just looking at Mr. Goya. I know I look good. That is not news. So take notes. Stop looking. I've always looked good. It's the age of the nerds. You've never seen a nerd in this age look bad. It's new age. Computer's going on. It's not just projected. Okay. So, are you sure? X plus x squared minus 1. So the log of x plus and plus the log of they want us to show that that is equals to 0. That's number 7. We need to show that that will be 0. So in order to show something is to prove it, right? Show me. Right? So you're asking somebody to prove it. So let's try to prove if this side will give us indeed a 0. If it doesn't give us 0, then that statement was not true. But they're telling us it's true. So let's try to see if we can logically get a 0. Before we do that, here is another Michael Jackson moment. Remember the time when we did polynomials, when we had this, how did we deal with this? Foil, that was the word I was looking for, thank you. All right? So we said this times that, correct? What was that? What's x times x? X squared. And then we said this times that also, what would that be? Negative xy, right? And then we distributed that. We also had an xy, but this time positive. And then this, we're giving me what? So if you look here, if I'm calling this whole thing y, and this whole thing y, that's exactly what we're doing here. Right? X plus y, x minus y kind of thing. We see that? So in this case, the middle falls off, right? Negative xy plus xy. So my answer is just x squared minus y squared, right? The first one squared minus the last one squared. Okay? We remember this because we did this. Now that we know this, SpongeBob, now that we're men, let's go back and do that. See that episode? Yeah. Okay, let's do this. So, first thing we know, addition is just multiplying the arguments, right? So, this is the log of x plus we're trying to see if this will give us 0, okay? We're trying to see if that will give us 0. Now I need everybody to watch because people are going to get lost in a second. They're going to be like, where you got that from? So just watch me, please. Watch me work and then you can nail it. Okay, let's do that. So, x times x. So this is just like you're back in the cafeteria during lunch break, right? Everybody walks through their buffet line, right? This is what they have to serve, and this is all of the kids, right? You go here, you get your whatever apple fresh, and then you get a nice food they serve you. They're gourmet lunch, right? And then the next kid comes also gets their apple. If somebody walks by there and their sloppy Joe is finished, they're gonna be mad. Like, why they got sloppy Joe? I ain't getting none. Right, the same thing. Okay, so this times that was just like we did the x times the negative y, right? Now remember when we did radicals. When we multiply, we keep the outside outside and the inside inside. So this x is outside of a radical, right? So it stays outside, it's a positive x. Well, actually, because it's a negative now. And then this x squared minus 1 is inside the radical, so it stays there. So I'm done distributing the x. This x I just walked through the buffet line at lunch, and it took an apple, and it took something else, whatever that is that you have for today's lunch. Cassava leaf.
Delicious.
Yeah. Okay, now we take the next piece, and this next student also has to go through the same buffet line and get the same food also. Otherwise, we're not being fair. Somebody's going to be mad. So, again, this is outside, and this is a positive, so it stays outside. This entire thing is inside, so they remain inside. Now remember how we did y times y, we got y squared over there? So this y times this y is going to give us that y squared. So here is our y, and it's a square. It's whatever we did over there back in the day, we still apply that here. We're still foiling. People still going through the buffet line during lunch. We're good? Anybody with a question? So now let's work in here. Just like before, negative something plus the positive of that same thing becomes a 0, right? Just like we had here. Correct? So this falls out, like Mr. Goya's here. Because it's, this thing times itself. What's anything times itself? Itself squared.
Oh,
So like y times y, y squared. Any other question? All right. So now we have the log of x squared minus, well, what does the square root do to the square root? They cancel out. Remember that whole story about Super America before they became Speedy and them donuts? Right? Speedway. Is it Speedway or Speedy?
Speedway.
Speedway, whatever they are right now. I know Super America. Right? It was like Super America, like a, you know.
Like essay.
Yeah.
I really want
Right. It's a Speedway. What are we speeding to go to Speedway? Right. But back to, you know, the donuts they had there. Remember that whole example? You bite the donut and the pus comes out.
I hate those type of donuts.
It's like the Ruby Tuesday burger. That you don't know which way to buy because all the meat is going to come out. Same thing here, right? This meat is just going to come out. Okay. I do, because I don't want you to be eating them donuts. Juvenile diabetes, it's real. I do that on purpose. I do that on purpose. And you'll be thinking it because it comes out. Making it pause. So let's do this. Fine, juvenile diabetes. Are we good so far? Let's bring it back. We're good? So let's continue working in here. So this is the log of x squared. Now this negative applies to everything in here. So you get a negative, you get a negative, everybody gets a call. Ooh, ooh. How you doing? So this is a negative x squared and a positive 1. And the x squared cancel out, right? Everybody see that? So what I get is the log of 1. What is the log of 1? What power do I have to raise something to get 1?
0.
0. Yeah, this is 0. X squared minus x squared. It's nothing. Okay. 0, right? Which is what we wanted to show.
What is that?
What?
Wait.
Question and subject.
If I came to this class and said the earth is flat, and you said no, and I said show me, what's that number page that you go to, that number website? That website is named after a number, and the parent company is Alphabet. What's that number website?
0.
No, it's named after a number you always go to. If I ask you to go search for something right now, what's the search engine you're going to use? That's the number.
Number?
Why is Google?
What?
Google it.
What? I'm so confused.
Google isn't.
Anyway, the point I was trying to make here is, if you want to find out what QED is, research it. Let's do the next one. Okay, guys. Let's remember now, because I'm about to do number 8. Number 8 and part of 9, I'm giving you homework. Number 8 says, if we are given, okay, here is what we are given. We are given that 10, 3.67. So x, y is equals to 10 to the 3.67. Here's the Michael Jackson moment I want you to remember here.
Anything raised to this number.
Yep, the log of base 10 of anything is just that thing. We know that because we say there is a 10 here. So we ask you, what power of 10 gives me 10 to the R? Okay? That's just R. We learned it. And another thing we need to remember is the principle of equality. This simple. It says whatever we do to one side, we should also do it to the other side. As long as we do that, we haven't changed anything. Okay? As long as I do whatever I do to one side, to all of the sides, I haven't changed anything. Nobody's going to be in the street demonstrating, right? Because we're doing it fairly to everybody. Okay? That. So there will not have been a need for the march on Montgomery, right?
On Washington.
Or on Washington. I'm talking back in the day when people had to cross into Selma and Alabama and other places, right? MLK would have had to march, right? Had we been following nothing. Same reason why people right now in Seattle yesterday had to march in some neighborhoods because police officers got us scot-free for shooting the kid 20 times in his grandmama's backyard, right? Same thing, 20.
20 times.
So,
I had to make sure.
that. So please, here's the thing. Your work is to look at 9, 10, 11. They got babies on the same page.